Welcome back. Good afternoon. As you all know, my name is Keith Salzman, ZK Dev, part of the applied, again, R&D team for Baseline. That's a really great picture of me. Yes? It's right there. It's in the picture. All right, and so today I'm going to be giving a talk called The Basics, okay? So one thing that we've kind of found with, introducing Baseline to people, it can be difficult as a topic to consume in a single sit-down, right? So we strive in these conventions to at least have one talk to go over the Baseline architecture, what we call Simplified for everyone, right? I think it's a pretty great name. We came up with the acronym first and just plugged it in there, okay? So if you are an advanced baseliner, maybe this talk isn't exactly for you, although hopefully you can glean some things about the kind of architecture behind the scenes just from the standards point of view. And if you are totally new to Baseline, or you've been involved a little bit in some of the open source, or even if you are not tech savvy, although I will dive into a couple of techie things, I think this is a great place for you to start and get an understanding to kind of develop those mental models in your mind that are really necessary to make it over that initial learning curve of understanding, what are the concepts behind Baseline? What are these strange, fluid architectures behind the Baseline protocol itself from a standards point of view? So there are a couple things that I will ask you to keep in mind during this talk, especially if you're new. That I'm presenting from the point of view that, the Baseline protocol, it is a protocol. It is a standard, right? So while other talks may be showing specific implementations, and those are great concrete examples to wrap your mind around, at any point in time, if I'm showing you some diagram or something, and you ask yourself, well, where is this thing? What does it exist? Maybe we're just saying it is existing and it is acting as it should be for the point of this example, right? And that the implementation in real life may look very different depending on the actual case. I wouldn't say use case, because Stefan doesn't like that. The example, right, that you are implementing, right? Okay, I think that's it. Are you guys ready to begin? You have your brains primed? Okay. Okay, there you go. So before we kind of dive into a real simplified example to kind of elucidate some of the architectures behind the implementation, or behind the protocol, the standard itself, just, of course, starting off with a little bit of background. So, of course, we have Baseline Protocol launched March 2020. We have the co-founders, Microsoft, EY, ConsenSys, open source standards project. So, as most of you probably know, you can get involved in any part of Baseline, whether if you're a dev, if you just want to be part of outreach, PR, really anything. All parts are open source. Anybody can get involved. This project is governed by OASIS, the open standards body. And of course, we have plenty, as you can see, all of our icons of all of these great sponsors we have here. So many great icons. Please look at them now. Yes, some of them are here today. Some of them are not. Okay. And just to kind of set the baseline, set the ground behind, what was the initial question kind of asked? And of course, I was not there during its inception, right? But what was the initial question, or something close to it, that Baseline, or the co-founders of Baseline, were kind of asking themselves to solve? Well, if you listen to Stefan, you probably got it, right? Which is that, in today's world, we have all of these enterprises who are holders of this complex data, and they are attempting to, or should be attempting to, communicate with each other, right? And although that does happen today in some form, that this can be very problematic in terms of how do we speak to each other in an efficient, low-cost way where we can guarantee we are are synchronized, and we have security, data integrity, all these things, right? So that is the kind of the baseline of the problem that the baseline protocol was seeking to answer, right? And so try to keep that in your mind as we go through. Now, so baseline, of course, has reimagined the way this is going to happen. And all of today, we're going to go through how that reimagination was built. We're going to look at it from a very simplistic point of view, right? So again, anybody can understand, all right? But again, before we dive in, I'm going to keep saying this, before we dive into architecture, because if we dive straight into architecture, I think we'll lose especially, maybe not anybody here, maybe you guys are hardcore baseliners, but the virtual side. So let's start off with a definition. So what is a baseline protocol, right? Try to carry this definition in your mind. We have a standard that enables two or more state machines to achieve and maintain data consistency and workflow continuity by using a network as a common frame of reference. So this is very, very basic, right? We have the standard baseline itself, a guideline, a railing for how to implement this thing. Two or more state machines. Today, we're going to focus on two parties, two state machines, but you can imagine, how this will expand to, in amount of state machines, in amount of parties. And we want to achieve and maintain data consistency, right? We want to always be synchronized, and we want to be sure that as we execute and move to the next state that we are already synchronized and hopefully in a trustless environment. So, and workflow continuity by using this common frame of reference. So we want a common frame of reference. We're going to see in today's presentation what I'm going to keep calling a CCSM, or a consensus controlled state machine. For many of you, of course, that means blockchain, right? But really, it could be any distributed ledger technology of any type, right? So the second definition here, the set of tools and libraries, I think this one is a little bit harder to wrap your mind around. You may be asking yourself, where are those tools and libraries? Well, the simple answer is that inside the baseline repo, while there are core packages that will help kind of define or interfaces of how and what tools should be implemented, that really, if you're looking, again, for those concrete tools, you're going to look out for those, outwards towards those concrete implementations, okay? So let's try to keep that in mind, all right? You guys got it saved in your brain? I see a couple of yeses. All right, there are these terms and concepts. I'm going to keep coming back to the slide if I can, if these buttons are fast enough, in case we need to define some concept from a diagram that we're looking at. There's a couple of things here. Again, the consensus-controlled state machine that I mentioned, CCSM. We have a couple things, a work step, a workflow, a work group. Right now, I'm going to focus on the BPI, right? So the baseline protocol instance, or sometimes implementation. So really, for us, these are logical constructs. They're shared, between transacting counterparties of, let's say, requesters and providers, and implemented on the CCSM. So I think it's difficult, unless you've been part of baseline for a while, to really, wrap your head around, what is this baseline protocol instance, and where does it exist? Out in the ether, online, off-chain, on-chain, and we're going to discuss that a little bit. But for a lot of the diagrams, we're just going to assume this thing has been implemented properly and try to see the overall flow, okay? In the next diagram, we're going to look at work steps, workflows, and work groups. So, within a baseline protocol instance, we have like a set of parties that want to engage in some transaction. In the examples I'll show, it'll be simplistically just like a purchase and order thing, right? It could be anything. It could really just be sending a message from one party to another. In this case, we're going to be buying some product, a buyer and a seller, okay? And we're going to look at the flow of just a work group from a high level, and then I'm going to dive into, in detail, how we go through the flow. So let's go ahead and do that right now. So, all right, here is a workflow diagram. This can be found in the standard. I like to use all of the pictures and diagrams and everything from the standard. In that case, that, after my presentation, I know you'll be thirsty for more knowledge, and you're going to go straight to the standard and read all the way through it, right? and you'll notice that we're using the same diagrams. You'll be like, aha, I've seen this before, I'm familiar. So here we have an example workflow. And in this workflow, let's say we have this work group, so a group of BPI subjects that have gathered together based on some agreement between them. So for example, if this was a buyer and a seller and they have some agreement of some product that they're going to transact between them, right? And we have a work group B. So work group B could be, let's say maybe in this simple example, something with a seller and a manufacturer or so on and so forth. So again, the examples today, they're not exactly going to mirror reality, but just, again, for simplicity. And let's say work group A member has some input for this work step, so that could be an actual purchase order, right? So if you decide to purchase something, and they may include, based on the agreement between the buyer and seller, the two parties, that information they've agreed upon, as well as some kind of, let's say, proof. In a lot of instances, you've seen us mention maybe zero-knowledge proofs. It doesn't exactly have to be a zero-knowledge proof, although hopefully I'll have time to get into why I think it should be, but some sort of proof to say that we have done what we need to do according to our agreement between them, and that work step will then, let's say, be the flow between the buyer and the seller will verify that proof, let's say, do what they have to do, and then there'll be some output, a change in the overall kind of shared state of the BPI itself, right? The state object that is passing that output will then become maybe an input to the next workflow, which could be something between a seller and a manufacturer. Just for example, it could be really anything at this point. And of course, work group B will have its own BPI subjects. It'll be governed by some master agreement or agreement that they have. And something similar will happen here. Again, transaction of data, messaging, depending on what's within that agreement. And then, of course, we'll have an output and so on and so forth, okay? All right, so this is just a flow for a simple purchase order, let's say without baseline protocol implementations or esque things going on. And I think I'm not going to follow it all the way through, but if we take a look, I think it's easy for most of us to imagine, okay, we have a request for a purchase order. We create the purchase order. It's been approved. The vendor receives it. We create an invoice, and it kind of goes back and forth, right? So there's not to say that there aren't, of course, guarantees in this current system today, but it's easy for us to see how this can get messy, right? How, maybe we go down through the flow and realize something is wrong, and we have to back up. There has to be some kind of manual reconciliation, and at what cost does that come, right? I think everybody here or online has obviously dealt with these kinds of things in their real life, and it's easy to imagine how we can have these systems in some kind of weird asynchronous state, and so on and so forth, right? So we set the stage. This is kind of the problem we're talking about. It's very simplified. There's two parties here, but as you blow this up, between n number of enterprises, the problem is exponential, right? All right, and so here is that kind of solution applied, the baseline protocol solution applied to that situation. All right, so this is where I'm trying to make the connection of, hey, that's the problem we had before. Now we're going to go through the actual flow in detail. I'm going to go through the flow in detail of, how do we guarantee that we can avoid having to go synchronization and all in, let's say, hopefully a trustless environment with ZKPs, again, my preference. All right, so we have the BPI in the middle. We're going to assume we have a correct implementation. It's doing whatever it needs to do with whatever specific implementation technology that you're working with. We have the buyer and we have the seller, okay? So let's say they already have an agreement between them. There's already we call it an MSA, a Master Services Agreement, between the two parties here that are in the BPI, in their own work group in the BPI. And that contract logic, which I'm going to say it's like a codified contract logic. They may have an actual like legal paper presentation between them or representation between them, but we're going to codify that logic. It's going to be part of the BPI into the CCS system. Again, we're assuming that is able to work and function. And let's say the buyer wants to make a purchase, right? So they make some kind of API call that will validate their order, what they want to order from the seller against the contract logic itself. So the contract logic that is living in here that dictates the rules of how these two parties interact, what's okay, what's not okay, already holds the logic to say, okay, well, you want to make this order, then you're going to have to provide this certain specific data, information, whatever it is. They do so, and then the BPI itself has this tool to generate a cryptographic proof that we are in compliance, and we can then update the contract state that this purchase order is in compliance so far, right? Now, what that cryptographic proof is, again, we're not worried about that right now. I keep having to make plugs, I feel like, for ZKPs, but there could be really any proofs that you want to use at this step, at this implementation, right? And so let's say we return that, the API responds with the cryptographic proof of compliance, and now we are ready as the buyer, if we see ourselves as the buyer, we are ready to send that proof off to the seller, right? Now, how we send that to the seller, whether in this diagram seen as moving through the BPI, or if we've set up a relay or some kind of messaging protocol directly between them, we're not going to get into the specifics. We're just going to say we have a way to transfer that message protocol over. We're going to submit the order with the cryptographic proof. So we have all that data required by the seller, the proof that we are in compliance, maybe hiding some private input, and we're going to send that to a place the seller can retrieve it, right? The seller retrieves it. They get the message containing the order and the cryptographic proof. The first thing they want to do is they're going to want to validate the proof, right? Again, in this case, simplistic, we're thinking of a single proof. It could be multiple proofs, right? Depending on the example. And so we're going to, as the seller, if we think of ourselves as a seller, we're going to validate that proof against the BPI. All right, so we validate that proof. At this point, we're either going to get a positive or a negative result. So if we get a negative result, we already know that whatever was sent to us, it is not compliant with what we agreed to, right? It doesn't need to go beyond that. This is not a valid order, right? But if we get a positive result, we have verified this proof, and then we say, okay, this is a valid order, and now we need to do what our side needs to do, which is to take the data or information from our system to say that we are accepting this order, whatever the order is, and we're going to do something very similar to what the buyer did, right? We are going to make a request to the BPI to generate the order acceptance from the contract logic. So again, dictated by this service agreement that are between the two parties, just as the buyer did when it first generated the cryptographic proof that it's within compliance, that its order is within compliance, that now the seller accepting that order. And again, you can use your imagination of what parts of, what data, what's going to be input here for them to make sure they're within compliance. And then they're going to do the same thing. This will generate a cryptographic proof that they are actually within compliance, and they will bundle that up with returning acceptance of the order, and they'll send that back by some messaging protocol to the buyer, right? So now at each step, we're kind of having this state change, right? You can think of it as like a single state object that's kind of moving in between. Here it starts off as the order with the proof created. It's validated, updated with the information the seller needs to put in, also bundled with their own proof, and then kind of sent back to the buyer to say, yes, everything's good, everything is in compliance on both sides. Let's send it back one more time so you can validate to receive that final kind of message from us to say, we're going to send you your stuff, whatever that is. All right, so they get that message. They validate against the BPI, the proof, and of course, they're going to get a positive or negative result. So we see at any kind of step here, whenever we have to verify the proof that something agrees with that codified contract logic that's already been agreed upon by the two parties, whenever we get a positive or negative result, that'll tell us right away if that party is acting in a way that we have agreed upon. And if not, then there's no way for us to reach that next state of which we have to go back and then do some kind of like manual reconciliation, like a asynchronized state. Again, just that we're unsynchronized in this case. Now, normally I would ask for questions at this point in time because I've gone over like a large chunk of something, and then I hope it does make sense to like the larger audience. But unfortunately, I'm going to maybe save it to the end, or if I run out of time, then maybe you'll just kind of have to ask me in person, okay? But I feel inside of me right now like the need to be like, questions, questions, questions. Okay. So up until now, we have kind of just assumed that the baseline protocol implementation or instance is there and it's working. And I think if you're really looking for a concrete representation that you can get your hands into and say like, aha, I see this is how a BPI works, I think you really need to look to those implementations. There are plenty of examples in the baseline repo itself, and as you go online and get involved, you run into those examples, and I implore you to dissect more than one to see that the actual implementation between them, really, there is a lot of leeway and flexibility if you're following the actual baseline protocol standard. I guess I can read through this really quick. So the baseline protocol instances or implementations, they're logical constructs shared between transacting counterparties of requesters and providers, and they're implemented on the consensus-controlled state machine. So I think depending on the example, right, in my mind, to say, how much of the BPI, which I tend to see as like a shared state machine, that how much of its functionality is on versus off-chain, and you're trying to consolidate that in your mind of exactly where it's at. I think that is best left for a specific example where we can see, okay, what part is where and what interaction is happening. And that's why I suggest you go look at those specific examples to see what differences have happened in their implementations to compare, what do you think has what advantages or disadvantages, and so on and so forth. But for now, we can think of it as just a logical construct that it's implemented on a CCSM, but in reality, a shared state machine where portions will exist on and off chain. Where we've seen in other presentations, there will be like a baseline proxy on top of a connector and so on and so forth. All right, so this is, again, another image from the standard. We have the baseline protocol instance. This is not part of it, it's a CCSM layer. This is just an example of a BPI, how originally it was designed. This gets kind of a bit technical, so I'm not going to go through it all, but we can see that, all right, within a BPI, we'll have, let's say, a middleware layer. And that middleware layer may have, a workflow section, a messaging protocol section that may exist, outside of the CCSM that may allow for kind of direct messaging within the BPI. Just for example, we'll have some kind of processing layer that may have storage. I encourage you to again to go and look at this. I think this is fairly technical in its representation if you're not a advanced baseliner. But I personally kind of keep this image aside as I'm looking through implementation to see, oh, aha, I see this is where they have done kind of workflows. Maybe this is their middleware layer. And it may not appear exactly as this all in this single layer, right? But if you can look through and identify, oh, aha, I've seen that they've have the business logic for dealing with workflows here, or the messaging protocols dealing with messaging between two parties, buyers and sellers. It is here. The virtual state machine here, the transaction pool, the storage, so on and so forth. This can help and lead you to shape that model in your mind of what should a implementation of BPI really look like, and what are the boundaries in shaping that BPI as you do an implementation, right? Okay, so now we're going to zoom out a little higher up. We did the whole, like one-by-one workflow that I really spent a lot of time on that you guys are probably really tired of, where I did step by step, and now we're going to kind of zoom out. Still the same simple example, right? We have what I call the mid-level architecture. So the mid-level architecture, we're not kind of fully zoomed out yet. We were down at the low level looking at like one by one, right? And now we're kind of zooming up and just saying, okay, well, this is how do I think of all these things kind of together? I saw the buyer, the seller, the BPI. So we have on the left, we have, let's say, a commercial transaction application from buyer to seller. And really, sometimes you could think of this in a concrete implementation as like a baseline proxy and a connector, with some legacy system off over there. And then the seller, same thing, some maybe proxy, a connector, and a legacy system off there. We have the state object, which is not only moving between them, but also through some baseline protocol core stack, that middleware and processing that we've seen, that we've discussed, how to kind of think of that shared state machine. And it's also kind of communicating with these internal APIs through the CCSM abstraction, where we can think of that as kind of housing our BPI contracts, the agreements that we've made between parties that dictate how they interact. How can we buy and sell? What do we need to include for this to move to the next step and be totally synchronized in kind of this trustless environment, and be sure that we have the data integrity on top of low-cost implementation from the legacy systems, okay? As if we can kind of, take this and map it into our minds of what we've learned so far from the low level, like moving back and forth between two parties. This is kind of the next level up of really how you'd start to think about where to implement things at, all those specific things that we abstracted in the last diagram. And then we'll take that and we'll kind of expand it, horizontally outwards to say, well, two parties, yeah, there are some cases, and it's easier to think about two parties. It makes it simplified for us. But, really, as you all know, and I stated in the beginning, is that this is about this large, multi-party, complex problem with enterprises, and it's never going to be that simple, right? Unless you and your friend just want to baseline something between the two of you, which you can totally do. And then so we move out and we say, okay, well, this is really, we're getting more towards real life of, we could have a commercial transaction application from vendor A to party 1, vendor B to party 2, vendor B to party 3, and, we kind of, use your imagination to expand out of, how many different entities could be, working in this BPI as part of a single work group of which the logic of how they interact is dictated, or what they've agreed upon in their own master service agreement, or they could be in separate work groups, as we saw in that original flow diagram, separate work groups that within a single BPI, or even, as we'll see later, maybe multiple BPIs with BPI interoperability, right? Okay, so I'll move on. All right, and so that's where we're at. This is kind of what I call this high-level architecture, right? So this is to complete in your mind the idea of, okay, at the very lowest level, two parties, buyer and seller. The next level up, in the first level, we assume the BPI is doing everything it needs to be able to do. We go to the next level up, and we say, okay, well, I need to know a little bit more behind the scenes of what this architecture looks like. Well, we're still two parties. We expanded it to 3, but we can see the different levels of kind of architecture. Still very kind of abstract and may not physically be represented as they actually are, but it still helps us. And then we zoom out to the highest level, where if you read through the standard, you can see that there are parts of the standard that apply to having multiple BPIs and them interact with each other, all right? We're not going to get heavy into details or anything on this, but this is just to say that the standard does have rules for this to happen, right? That you can, if you abide by the standard, you can have multiple BPIs. Name them Alice, Bob, and Claire, but maybe this is just the person who was the first person in the BPI or in the work group, right? How it's named. And they are all, in this case, communicating by a single state channel on which we may be using possibly multiple CCSMs, okay? So you now have those 3 tiers of understanding of kind of a architecture of what can be done with the baseline protocol. All right, now, that is kind of somewhat the end of the technical of me trying to help you understand the basics, right? To just give you that kind of liftoff to overcome the, that steeper curve of what is baseline, what is this kind of amorphous thing in my mind to help shape it to something that you can imagine and work with within your mind as you're entertaining examples. Okay, so I hope that has helped. Of course, I have to talk about some companies that were inspired by the baseline pattern, right? This is one of the kind of great benefits of having a baseline R&D team is as we think about these implementations, we happen to have many spinouts on ideas that were originally baseline. So we have this was the original question itself that came as a spinoff of how can we enhance current asset diligence practices to allow counterparties to verify asset performance without exposing sensitive data. I'm not sure how deep you have to be in to come to that question itself. It seems like a very, deep in thought, philosophical, financial question, but somebody asked that question, right? And that led to InLabs, so a facilitator and issuer of real-world assets, pools, and DeFis. And of course, if anybody's been paying attention to any of the baseline shows or any time John is on anything at all, this is the question: how can we use the pattern to enable cryptolithography and digital rights management to protect originals for NFTs? That was the question that John was asking, which I think is a little easier to digest than this one of how did you come to that, what thought process led you to that point. And this has led to, of course, treetrunk.io, the first multi-party royalty-bearing NFT marketplace. So we hope to have many more spin-outs. My team and it's not really my team, I'm part of the team, Sonal's team, to shout out to the virtual people. Sonal's team and I, have a lot of stuff we're cooking up, so we're hopeful that in the near future we'll have many different spin-outs, okay? So just a shout out to that. All right, so with that great amount of knowledge that I've transferred to you now, as a new baseliner, let's say, or a middle-level baseliner, the advanced ones, you guys already know what you're doing, is how do I contribute to the protocol? Or really, for me, when I originally wrote the slide, it was what do I do next? Where do I go? Or something like that. So I encourage you to actually read the standard. It's a great read. It's perfect, not boring at all. I do encourage you really to read it. Sometimes you're going to have to put it down and pick it up, but definitely read the standard, right? Now, if you only just read the standard, maybe it's difficult to put that to what we've learned today, those models of the architecture. So in addition to reading the standard, look through the existing examples. Read part of the standard. It'll go over, let's say, BPI implementation or one focus of the BPI, and then look through the examples that are online and say, I've identified, I've made this connection. Here is how it is in this implementation. Here it is defined in the standard. Here I see it in the diagram. How can I connect these things in my mind? Do I agree that this implementation, in fact, does follow all the things in the standard? And while you're reading the standard, the thing that I've heard and I like to say is the standard is this living, breathing piece of work. No matter what Andreas Freund says and how great he is, I think his intention is for you to question it. And he welcomes this questioning, and so do I. When you're reading the standard, question it, right? When you're looking at implementations, question them. Is this the right way to do this. We are actively and always having standard meetings and revising the standard through all kinds of critiques that people offer, right? So read the standard, look through those examples at the same time. Again, in the original slide, then number 3 was read the standard again, but with a more inquisitive outlook on life. But my business and PR team told me to take that away, and to them I say, too bad. No, all right. And then, view all the existing resources. Go out, reach out to implementations that are not just in the baseline repo. We've seen today here people speaking today, and even ones that are not here today, reach out and see, look at previous baseline shows, demos, technical walkthroughs, and then contribute to the work. So it doesn't mean that you have to be a dev. I'm assuming that a lot of you here are either a dev or business side, but for anybody here online, contributing to the open source work is much more than just being straight technical developer, right? There's a lot more to it. You can be kind of part of the community, help out with the standard itself, help with outreach to get people involved in baseline. There's really many ways, way beyond the scope that I know, that I would say probably only Sonal Patel is aware of in operations. But the first way to start is our nice Get Involved link, okay? So, how do I contribute? That's how you contribute.